Welcome to the 8th episode of Tox Chat Box, a SciEx podcast series where we discuss the latest trends and applications in forensic toxicology. I'm Pierre Negri from SciEx, and in today's episode, we're discussing the process of relocating a toxicology lab, which included a fleet of over 60 LCMS instruments. And to discuss this topic today, I'm joined by Dr. Victor Vandell. Victor is the Science Director for Pain Management, Special Chemistry, and Toxicology at Quest Diagnostics. Hi, Victor. How are you?
Hey, Pierre. How's it going?
I'm great. Thank you. First of all, thank you so much for accepting my invitation. I remember running into you at a few conferences last year, and you're kind of telling me that you are in the process of planning your lab relocation. I know you've been super busy for the past year, planning and executing the big move. To start things off, can you talk to us about some of the timelines of this relocation and maybe provide some details on the scale of the move?
Well, essentially, our goal was to move a pretty substantial size drug testing lab. And with that, we did some consolidation and thought about how we were going to sort of take this relatively large West Coast lab and move it to another facility. You know, I told you we were looking at moving 60 plus triple quad mass spectrometers, three big Olympus 58 or Beckman 5800 immunoassay analyzers, and these are the big boys, along with about 12 Hamilton workstations. We had a lot of support equipment, ALD units. We even moved over a GC mass spec set up for blood alcohol testing, and just a lot of different things had to come over. And that's not even to mention all of the lab gear and equipment, glassware, consumables, all of the stuff needed to support all of the testing equipment and instruments that we were going to be using, in our day-to-day drug testing. So we needed to come up with a plan to do this. And initially, when we started out, time frame wise, we had approximately 4 months to get this done. Now, part of the challenge that we had to deal with was not only did we have this massive amount of equipment to move, but we also had to work under the premise that the lab will never stop functioning. So in other words, the lab we're moving from, which is putting out thousands of samples a day, that process cannot be interfered with as we move the lab. So we had to it's almost like a plane that's being fueled in midair. But then at some point, find that magic part where you can flick on the light, so to speak, at the new spot, and then let everything run and result from the new lab, while then coming back and bringing over everything from the old lab to the new lab.
Wow, it sounds like quite a substantial move, and like you mentioned, quite the balancing act, right? Putting all the moving parts together must have been quite the endeavor. One of the requirements that you just mentioned for the move was to maintain current laboratory production activities at the first site, right? While moving and verifying instrument performance at the new site. I remember you mentioning using Gantt charts to plan and kind of execute the relocation of the instruments. Wanted to ask you how critical it was for you to use these charts, and maybe can you describe how you leverage this visual management platform for the relocation?
Yeah, the Gantt charts were invaluable to us, not only because they gave us sort of a big picture view of what needed to be done, because everything was going to be on sort of this real synchronized timing between all of the players involved in moving, say, an instrument from spot A to spot B. Okay, the Gantt chart is what helped to organize all these moving parts. So with the Gantt chart, we had a schedule set up in there where, okay, this is the time that the instrument's going offline, and I had all the instruments listed out in these massive worksheets, Excel worksheets where the Gantt charts were. All the instruments were laid out. We laid them out to be moved in an order that would allow us to keep running the major provider instruments for our day to day, move all the secondary back and backup instruments first. Now, in that Gantt chart, not only did we have to have the time frame for, or the lineup of the instruments that are going to get moved in the order they're moving, then we have the lineup of how much time it's going to take for the vendors to come in and do the initial specking of the instrument prior to pre-move. Then we gave our scientists I think we gave them 3 days to do the pre-move verification and run all of their tests to get the verification. All of this is laid out on the Gantt chart. Then another day for the decontamination. Then another day for the move, okay, which usually was like the next day or 2 days after. Then we would allow for, once the instrument got over to the new site, I think we allowed for 3 to 4 days for the vendors to spec the instrument back. You have a day would have to be used for pumping down the instrument, of course. Then they would have another 3 days to do all of the specification testing to get the instruments back up, communicating and spec'd out as if they were coming in off the crates. Once that was accomplished, then we would give our scientists another 3 days to do the post-move testing verification and to verify that the instrument's good to go. So, the whole evolution of moving the instrument overall would be approximately about 2 weeks per instrument.
I want to go back to one of the things you mentioned from an analytical verification standpoint. Can you talk about some of the method performance verification process and pretty much all the boxes that had to be checked on your end before you could actually use the instruments in a new location in live production? You mentioned carryover, accuracy, precision. Can you maybe elaborate on that a little bit more?
Yeah. So, one thing that we had to get a feel for, and you have to think about when you're going to do a process like this, is, what things need to be tested to demonstrate effectively to anybody who wants to, review your process. What things have to be done in order to show that nothing has changed in this instrument's performance or the performance of our method on that instrument, and that we're going to get the same answer from in location A and in location B, okay, with the same instrument. So obviously, we do a lot of validation and verification of assays all the time here. We've got so many different, testing assays that have to be validated or re-verified. So, you got your core test that you always want to do, which are carryover tests to make sure, that the instrument isn't, the instrument's clean and doesn't have residual analyte from previous testing lingering around and impacting future results. So you want to make sure the instrument's clean and doesn't have any carryover. You're going to want to do precision testing. Running a series of QCs. And you set up your rate. Some places might say, "Hey, give me 5 QCs over 5 days," or give me 3 QCs over 15 days, whatever your process is. And then we did linearity. Okay. So linearity is just basically demonstrating that, our assay is linear. We do all that stuff in the pre-move. Then we took the plate that we used to run the pre-move and we froze those plates at minus 20 degrees C. And we did a lot of extensive testing to verify that the plate and the analytes in the plate would be stable at minus 20. And we found that we could leave a plate in the freezer for, up to some analytes 6 months. So we had started testing this like way out before we started moving as to how long we could freeze our plates and it would be stable for us to pull them out and rerun all of the same quality tests when the instrument gets moved. So once we ran all of those technical tests, we would freeze the plate. The plate might go in the freezer for a week or two until it's time for that plate to come out and that instrument's been moved to the next spot. And then we turn around and rerun all of those same assays again, and then correlate the data to show that the data was the same pre-move as it was post-move. This instrument, therefore, is performing back to spec as it was before it got moved.
Great. Thank you for walking us through the process. It's very meticulous and very well planned and executed. So, congrats to you and your team. Now that the dust has settled, you told me you're in a new space, full production, right? This is all behind you. Looking back, can you pick one thing that you planned for that worked very well? And maybe the opposite, one thing that you planned for that didn't work so well or that ended up being problematic? I know you mentioned the construction delays.
I like to let me outline the good stuff first, okay? And there was a lot of good stuff. Actually, it was a lot of great stuff that happened, and part of that was our planning was impeccable, even with the obstacles that were thrown in front of us. Again, we would just change our dates on our Gantt charts, and everybody would line up, and we'd make sure that we're still covering our bases, and people performed very well. Our team of scientists, our team of project planners, our vendors, the movers, everybody was on point pretty much when they needed to be, and they executed when it was time for them to execute. So that was the great part about it. And I have to definitely give kudos to my scientific team, production and our R&D team here at Quest for this move, because they were the ones who were in the trenches with the instruments and running the tests. So I think the best part about all this was just watching the team execute it and get it done. Now, on the bad side, the things we couldn't control, construction of the lab. And, at one point we started to move, and then we were told as we got going, oh, there's something going on. Inspectors, need to do this, or they aren't happy. You guys got to halt what you're doing because the inspectors want to go back in there and look at this, which caused a lot of, well, of course, it jammed the Gantt chart up. So now we're, the Gantt chart screwed again. So now we got to, go in and make amends to that. And we got hit in one point of this process. We got hit with a super long delay. We was, and we were trying to get going. We kept being told we're gonna go, and then the construction and the inspectors would say, "No, we don't want you to do this," and then we'd have to stand down. And it got to the point where we were just kind of numb to it all.
Great. Well, thank you so much for this very comprehensive and thorough retrospective analysis. That was quite the project that you're in charge of. So congratulations to you and your team on a successful move.
Thank you, Pierre. It was we got it done. Check it off in the book. I mean, and on the other side of it is such a relief.
That's great. Thank you so much for all your insights and sharing all your experience. I really appreciate it. That's a wrap for this episode on relocating a fleet of instruments to a new lab space. Again, thanks to my guest, Victor, for taking the time to share your experience. I really appreciate it. Thanks for joining us today. In the next episode, we'll be joined by Justin Poklis, the current manager of the Pharmacology and Toxicology Mass Spec Laboratory at Virginia Commonwealth University. He's going to talk about the use of mass spectrometry to track the evolution of designer drugs in both the legal and legal drug markets. So make sure to tune in for that. Thank you so much, and we'll see you next time.